Hello everyone and welcome back to my classroom. As always, I'm Professor Leo, and before we start, I want to apologize for the long absence in new content on the channel. Some issues with my personal and professional life came up, and I wasn't able to sit down and record for quite a long time. For today's lesson, I'll be teaching about save files and how to implement our items in an inventory system. So, for starters, I've already set up a simple resource for the save files, as you can see, using the knowledge from the previous video. It contains the position of the player and an inventory represented by a dictionary of item and int. Item as our key and int as our value. So for example, if I had an item called, for example, an apple, and I had an amount of 2, the key would be the apple and the 2 would be the amount in the int. So we will eventually add more properties to the save file, but for now I want to keep things simple. To start, let's create a save handler that will be an instance node like we created previously for the game management, and it will keep track of our save files and handle the logic of loading and saving. So let's go into here. I'm going to create a save handler, and it will be an instance node of type save handler. And now let's start by putting our constants, which will be the save game path and the max amount of save files we will have. Next up, let's create an array of saves that will represent all the save files in our folder. And next up, let's create the save game method, which will take in the position, the inventory, and the slot number. Slot number in this case to represent one of the many save files we can have in our folder. So let's start by void save game. First parameter, a vector2 of position. And second is a dictionary. Okay, it's not importing, but alright. Of item int and inventory. And finally, int slot equals 0. This by default will have the value of 0, so slot 0. You can just pass, for example, the position and the inventory, and it will automatically save to this 0 slot, which would be the first one in our save files. Now let me import system numerics pause and create our save. Or save new save. That's in the position, the inventory, and it's in here. It's a vector 3 and not a vector 2. And it's not the system numerics, it's the Godot vector 3. And there we have it. For clarity's sake, let me just change that to var save. And now let's build our file name. So var file name is equal to string format of our save game path with the slot, just like that. Because if you notice here, I have a 0 between brackets, which will be the first parameter I pass in the string format will be replaced here. Okay, and now resource saver.save and file name save. Let me just check. Okay, I might have switched both of them around. Let's save file name. Simple mistake to make. And now save slot equal save, which will basically say I want the save at slot 0 in my array to be this save I just created. we load in the save files into our array, which will basically be loaded in the, if I'm not mistaken, ready function. This is basically the equivalent of the start method in Unity. So let me start by going into for slot equals 0, slot save files, and slot ++. Let's iterate over our possible save files in our user folder, which will basically be this part here. So let's start by getting the file name of the possible slot existing, string.format, save game path, and our slot. Okay, if results loader .exist, if our file exists in the folder we specified, then we are going to load it. So var save equal resource loader dot load file name, and might need to convert this to a save. Yeah, basically we pass in the save parameter in here, which will basically convert whatever we load into our save resource. And now let's add it. So saves in slot equals save. Alright, and basically that's it. Base ready, and it will continue as it should. And now let's just leave in here the void for the load game. Slot equals 0. Later on we will fill this in to basically map to our player and the inventory correctly. And now to set up our inventory system. Let's go back into Godot, and in our player, let me just rename this as the player, just so we know. We are going to add a child node. It's going to be an empty node 2D, and I'm going to call it not an empty node 2D, just a simple empty node, and we'll call it inventory. This will basically be our inventory holder per se. So new script, inventory handler. Let me just check it's correct. Put in the runtime folder, inventory handler, and yeah, now it's fine. Okay, it's part of the node. And now in our player, let me just add in here a simple mention to that inventory, so we can later on access it to add an item, check what items we have, consume items, etc. So public inventory handler inventory. Okay, and now as soon as I build this, it should appear as okay. It didn't. Let's check what's going wrong. Oh, I'm missing a partial in here. Okay. Anything else? Yeah. Exported is not supported. Okay. Basically, I can have this export here. Later on, we will basically rebuild the dictionary into a new type that will allow exporting and showing in the inspector. So now let's try and rebuild, and it should be fine. Now if I go into the player, there it is, inventory. Let's drag it in, and done. Okay, while we're here, let me just go into my project settings, and in the autoload, let me specify that I want to add my save handler as an autoload as well. Add, and there it is. Now it will start when the game starts, basically. So now let's continue building our inventory. In here, let me go into here then, and let's begin by creating a similar dictionary to the one in the save file. So private dictionary item int inventory. Let's initialize it, and there we have it. And now let's create our method. Start off, let's create the add item method. Public void add item item, and we can pass an amount as well. Let's default it to 1. Eventually we might have some cases where we want to add more than 1, and we just pass it there. So let me check if it already exists. If inventory.hasKey or contains key item, then we are going to go into the inventory. So we are going to try to get the value. So inventory.try get value of item out int amount, for example, and let's just say inventory where item is going to be equal amount of item plus amount. So we are going to increment by the amount we pass here. Otherwise, we are going to go inventory add item amount. And there we have it, the add item method. Okay, for the next phase, let's go into the item class, and I'm going to add 2 flags, or 1 flag in the method. So first off, public bool consumable to determine if our item is a consumable or an equipment or whatever we want to call it. And another method that will be virtual. So virtual void consume, which for now will be empty, but we can implement some functions for whatever we want to use it for by just, for example, if we inherit a subclass, for example, an apple, that will be an item, we can just override the void consume and basically handle our code there. So for example, health plus equal 10, for example, it will just call it like that. And that will be used in our inventory handler as a public void consume. Let's say item, and then let's say if inventory.hasKey or contains key, I keep getting that wrong, okay, we are going to consume it, else, or I don't even need an else, I can just return. Basically, we are going to say that we don't have that item, so we can consume it. We can even say gd.debug, or what was it? Print error. So we are going to print an error that says item not found. We can even go into here and say item.name. Okay. Next off, let's say we are going to if inventory.tryGetValue item here of int amount, and we are going to say if amount bigger than 0, we are going to consume it, else we are going to print for now a GDR and say not enough items in inventory type and item dot name. Okay, so basically if we have 0 items of that same name in our inventory, we basically can consume it. It would be an error. So there we have it. I'm also going to return. Now let's just handle it like this. Eventually we will want to handle it in a different way, like for example showing error message in the screen or something like that. So if amount is bigger than 0, next off let's just say if item.consumable, we are going to consume it, else gd.printerror item.name not a consumable. Okay, and in here we just convert this into an else. Okay, and now item.consume and then inventory where we have the item is going to be equal to amount -1. Okay, and there's our consume method. Finally, let's remove an item from our inventory or call the method for that. So void remove item and int amount if inventory dot contains key item inventory if inventory dot value. This is basically a simple way to avoid any possible exceptions that may eventually come out of the get value. Output value and if value bigger than amount, we are going to reduce it, else gd print error emptying remove more items than the existing in the inventory of, and then call it item.name. Let's put the $sign here. And basically this will stop you from, for example, removing a 4 of an item where you only have 3 or 2 or whatever. Okay, so inventory item is equal to amount value minus amount. And basically that's it. That's our inventory handler, somewhat already built. So what we can do now is to test this inventory. We can go into the ready function and, for example, initialize it with some sort of item. We can even try to export in here the initial item for testing. So public item and call it test item. Okay, and in here we are basically going to say add item of type item and 1. And in here, let's just say remove item, and oh, in here I can just say 1. And there we go. And now we can just, for example, say save handler instance.save game. Okay, I can do this here, but I can use it in the player function so I can save properly. So in here, let's just say we are going to have a test method here, which we can remove later on. Test inventory is basically going to add the test item to our inventory. Okay, and in here, inventory dot test inventory and save handler dot instance dot save game. Let's pass in our position, which we have somewhere in here. No, it should be, yeah, there it is. Position inventory dot, let's implement also a get inventory method. So we're going to here, dictionary of type item int, get inventory. It will return our inventory and inventory, and basically that's it. We don't need to pass a slot. So let's first go into Godot and build, see if it builds properly. It does. We have a test item that's possible to load in here. So go into resources, test item. All right, and let's test the code by running the game. Okay, at first nothing appears to happen, but let's go into the %appdata Godot app user data folder. I'll have it linked below, and let's go into the folder belonging to our game, and we have a save game _0.res file there, which means we at least managed to save the game properly. Let's open with, and let me select, for example, Notepad, and we basically have something in here that should be the proper representation of what you want. So we have the vector3, and we have the resource, which would be the item, I presume. And there we go. That's all for today. Next lesson, I'm going to teach how to implement item pickups, and we'll create the new dictionary type that I mentioned previously that will allow us to easily use the inspector to see what we have in the inventory. I hope you enjoyed today's lesson, and if you did, be sure to hit that like button, leave a comment down below with your ideas for future lesson, and don't forget to hit the subscribe button and activate notifications so you don't miss any of the future lessons. That's all for today. Leo signing out.